Ever wondered what happens to us when the sun dies? Before we go there, let's briefly look at how the sun was formed. Physicists believe the sun formed from a large, dense region within a cloud of gas and dust, called a solar nebula, approximately 4.6 billion years ago. The collapse of this region under gravity led to the formation of the protostar that began to spin faster and faster, its center getting hotter and dense and eventually becoming the sun. Let us briefly examine the evolution of the sun as predicted by scientists. Scientists believe that in about 5 billion years, the sun, in line with evolution, will enter the red phase, helium phase, planetary nebula, and finally white dwarf phase. The red giant phase is a stage of a star's life where it runs out of hydrogen fuel, it swells large enough to engulf the inner planets, including Mercury and Venus. It becomes redder and brighter, or luminous. From the red giant phase the sun will move to the helium phase. This phase marks the transition from hydrogen burning to helium burning in the sun's core and a formation of carbon and oxygen. The next phase is planetary nebula where the outer layers of the red giant are expelled into space. What remains is a glowing shell of ionized gas that surrounds a dying star. White dwarf is the final stage of a low to medium star's life cycle. The sun will end its life as a white dwarf, a dense, Earth-sized remnant of its former self. White dwarfs gradually cool over billions of years, eventually fading into a cold, dark object known as a black dwarf. Now that we have understood the evolution of the sun from birth to death, let's examine what happens to our life on Earth during these phases. A recap of what the sun does for us on Earth. The sun is like our huge nuclear reactor. It warms the seas, shines on us, warms us, provides energy for plants to grow. It enables plants to generate oxygen by means of photosynthesis, which humans and animals need to breathe, makes liquid water possible, controls the water cycle, evaporation, cloud formation, and precipitation, stirs the atmosphere, generates weather patterns, while predictions about the exact fate of Earth's orbit are complex. The expanding outer layers of the red giant sun may reach and engulf the inner planets, including Earth. Earth will become a scorched, lifeless rock, with no atmosphere, and its oceans boiled off. What happens to life on Earth when the sun dies? As the sun approaches the end of its life, particularly during its transition into a red giant, several significant changes will occur that could have profound effects on any remaining life on Earth. Here are the potential impacts on life. Increased solar brightness. As the sun evolves into a red giant, it will increase in size, and its brightness will intensify. This extra intensity is expected to have significant effects on Earth's climate, like the heating and evaporation of Earth's oceans, causing the water to escape into space. Loss of atmosphere. The intense solar winds could strip away Earth's atmosphere. Damage to the atmosphere can damage air quality and increase exposure to harmful radiation. The outer layers of the sun, expelled during its red giant phase, will create a stellar wind that might blow away the remnants of our planet's atmosphere, making it uninhabitable. Potential destruction of Earth. The expanding outer layers of the red giant sun may reach and engulf the inner planets, including Earth. It is likely that the outer layers of the sun will extend far enough to envelop our planet. This process would lead to the potential destruction of Earth. Without the sun, Earth would become a frozen, lifeless planet. The absence of sunlight would cause a rapid drop in temperature, making it impossible for life to continue. This would mean the end of the agricultural industry, and people would no longer be able to grow crops or feed livestock. Most living organisms would die. Even those who burn coal and wood for warmth, they would eventually die from hunger. Transformation into a white dwarf. After the red giant phase, the sun will shed its outer layers, leaving behind a hot, dense core composed mainly of carbon and oxygen. This core will become a white dwarf, a cold corpse of a star, a stable, Earth-sized remnant that gradually cools over billions of years. The evolution of the sun is a natural part of the life cycle of stars. Considering these events, it's clear that life on Earth, in its current form, would not survive the sun's evolution into a red giant. However, the timescales of 5 billion years means that human civilization would have also evolved and undergone significant changes beyond our comprehension.